Oh, it seems our webinar started, so recording started. I see that the second started to go, and so waiting for our participants of our meeting. And so I hope people from the LinkedIn, from the web, from the Facebook, from the YouTube will be connected to our webinar. So we will need to wait a little bit, and so because you know how it happens. So I think we are ready, our team ready, and we will start from our introduction, and so from our favorite topic for our company, for Apriorit company, and because Apriorit company working in the cybersecurity market more than 21 years. And so we are very experienced at beginning from the low level of operating system and in the cloud level. But today we will share our expertise related exactly with the kernel experience for the Windows. And today with us, our main speaker will be Victor Mulakum, who are working in our exactly in our company only 18 years, and so worked with the different type of projects. So beginning from the project for startups, which implemented from scratch, from the some minimal driver and with additional functionality in the middle layer and upper layer, and also participated in the Mammoth project with the legacy drivers and participate in not only implementation of that legacy driver and even participated in the moving this legacy driver to the new technologies in the newer separating system. And also together with you will be me, Claudia Zik. I also worked and near to the kernel projects in the Apriorit company. I started like quality assurance for the kernel project. I know how to use driver verifier. I know how to use WinDBG and how to analyze memory dumps. So it's also a favorite topic for me, and how to implement kernel solution for the cybersecurity and functionality for this type of solution, and how to provide quality and high quality level for this type of project. So what I can tell you, we are ready to see our participants in our webinar, and so welcome, and a lot of our guys from the different sides of world, and one of them from the Canada, other from the USA, some guys from the Israel. And so happy Hanukkah for guys from Israel. I know that today's evening you are starting to celebrate Hanukkah. And so I think we can start. And Victor, are you ready? If you are
Sure.
ready, we can get our webinar started. So please, your turn. And
Sure. So good day, everyone, or good morning if you're from our continent. And yeah, so people are writing right here something. We will continue. So please write to something to chat if you have some problems, or you can hear, or something like that. We have kind of notifications here. And yep, so today's webinar is about exploring Windows kernel extension opportunities of cybersecurity solutions. And first, we want to kind of summarize and kind of sketch potential subset of tasks that might be interesting. Sorry. Yeah, that might be interesting when we develop some cybersecurity solution. Sure, cybersecurity is a huge area, and we will not try to handle the entire concept in a single webinar or something like that. But here we have kind of, as I said, a sketch of interesting tasks which cybersecurity solutions usually do. And the first item, as you can see, is custom access control tasks. The huge category, here we have data protection system, endpoint data leakage prevention system. As you know, any modern desktop operation system already offers an access control system, but it usually is user-based and doesn't include some important concept like sensitive data, accessing, publishing, copying, verbs, and so on. So that's why people usually do custom access control system. Then we have next topic is data encryption. It's pretty common and effective security method for protecting organization information, which we also do. And next item is malware protection. Malware is malicious software. So any software designed to cause disruption to computer, server, some client or computer network, leak private information, gain unauthorized access to information system, various antivirus tasks are here. So it's like a huge thing also. Then interesting part of cybersecurity for us is host-based firewalls. It's about, so it's what is host-based firewall is like software which runs on individual computer and protected from some malicious network activity from inside and outside as well. So mostly targeted outside, but who knows? Yeah. Then next thing is incident detection and response. So it's kind of wide topic, and it's about developing the technologies for detecting and responding to cyber threats and security breach, cyber attacks. Security breach basically is a security violation in which also sensitive data or protective data is copied, transmitted, stolen, or by some individual who is not authorized to do this. So yep, so huge area also. And another item is data backup and recovery, which also belongs to this cybersecurity area. Yep, it's interesting in our context of webinar. And backup and recovery is a process of creating and storing copies of data. Also can be used for protecting your data against data loss.
So. Yeah, maybe this direction of drivers, maybe not the cyber security, yes, and comparing to the previous mentioned items, but it's really complementary domain of cybersecurity. And because
sure.
when you are doing backup and recovery, we are working a lot with a lot of sensitive information, and so that is why it should be done following the special regulations, so the high level of quality, and so that is why this is like one of the topic of cybersecurity domain.
Yes, and this method is why it belongs to cybersecurity, because of usually it's widely used against, for example, ransomware attacks. So you have to have a data backup and recovery system, and it would help a lot with ransomware. Nowadays, it's kind of big plague all around the world. So yeah, and as we said, we will target Windows platform mostly, but if you have questions about other operation system, we can also answer them, I think. So let's go further. And yeah, and here we have, if we talking about kernel extension, let's talk about user mode and kernel mode, and where we can load some kernel extension on driver. And yep, so as you can see on this slide, we have process address space on Windows. On the left side, it is user mode address space, and on the right side is kernel mode, and it is simplified scheme which depicts only main address space. It doesn't include transition space, session space, other different processor-specific spaces, and which I'm not interested in right now. Yeah, but you can see how access control, for example, how execution sequence goes from some application to kernel and call some function. So this slide kind of depicts interaction between user and kernel space. As you may know, kernel address space is mostly common regardless of which process the execution control came from. So left side is, if we go through all the process on system, left side will be changing constantly, and the right part is mostly common. And this is protected area. Windows protects address space from code patching, from kernel object manipulation attacks, and from influence of user model as well. So
each time as I watch on this picture, I see something ununderstandable for me in the bottom of this. I hope this is very censoral.
Yeah, essentially, this is just the addresses. So here, yeah,
Okay.
to some thesis about kernel mode. So kernel mode is sure secure protected perimeter, and as we know, operation system they use CPU concept called protection rings to protect in order to protect the data and operation system components from user space. Yeah, and user mode code can't access kernel memory, use kernel handles, and bypass some access check, which offers any operation system. Yeah. Another interesting thing about kernel mode that if you want to develop your kernel extension or kernel driver, you must sign it. And kernel driver must be signed for the driver to load. So, and it means that software vendor has to order the special extended validation certificate. This includes not only payment, but also identity verification, usually by the phone too. And the certificate, it is not just downloaded. When you buy it, it comes like hardware USB token, and also takes time to deliver. So it's not very kind of convenient thing. So it's a kind of disadvantage of working with drivers. And then the software vendor has to register the company at Microsoft Hardware Development Center and so on, sign the driver. And there are a lot of steps which are available on the internet. Microsoft changes them from time to time. And yeah, but also for hardware vendors, it's a nice thing that there is special optional step which can be valuable then Windows Update integration. It requires additional step, but you can integrate your driver with Windows Updates as well. Yeah. And last item here is development requires an experience. Sure thing. So as we said, the kernel space is global, and that's why any mistake you make would eventually affect the entire system. The driver functions are called by multiple threads simultaneously, and you need to be proficient with multi-threading and synchronization and memory leaks, bad memory management, heap corruptions, multi-threading races affect the entire system immediately. So you need to be careful and do a lot of testing and use some automatic toolkits. And but first thing is you need to know what I'm doing actually before starting activity there. So let's go to the
Yes, and you need to know what is a driver verifier because it's a very sensitive topic for me and for our end user. And you need how to use it for testing your radio driver.
Yeah, because of if something bad happens, it happens globally. Yeah, let's talk about user mode. So what are advantages of having user mode part of cybersecurity solution or some kind of system programming? First advantage is that there are only only data sources, I would say, like that. So for example, we have a few examples on the slide, like COM, GDI, keystrokes, clipboards, different RPCs. COM looks like technology from the 90s. I think some people might say, what is it? COM is already dead, but it's not like that. Microsoft introduced new interfaces from time to time. It is still de facto one of the standards of inter-process communication on Windows, so you have to deal with it if you need to solve some different tasks regarding to inter-process communication as well. So, and there are other data sources that are challenging to catch in kernel mode, like ALPC and other internal interfaces. Yep. Then interesting thing about next interesting thing about user mode is user mode handles are usually less limited to their capabilities. So, for example, you can show some UI or use RPC in your handler if you have some handler which handles some activity in user mode. You already have process and user context. You can do an RPC call and so on. So you have kind of not very limited comparing, for example, to some device driver which handles interrupt request. So it's completely different capabilities. And and handlers usually have valid process and user context as well. Sure thing, user mode approach components, they have disadvantages. So first, I would say it's like well-known disadvantage is weak protection against direct attack. So it's natural thing that because of any process can modify its own address space. And if you can, for example, do some splicing, hook some functions, then the process also can, any user mode code can remove any hooks, like also keyboard hooks, Windows hooks, any window-related handlers. So kind of user mode is a place where different code can fight each other all the time. Yep, and yep. Another big disadvantage is that usually you need to have some injection into target address space. If you don't have it, so you need to implement it. And in some cases, it's just impractical. For example, if we are talking about file systems or network stack, then it's just impractical because of user mode function. So functions, they form kind of large set comparing to kernel mode. So if you have potential set of 4 functions to intercept the entire traffic of your personal computer in kernel mode, you need to have like 100 cases in user mode. So it's really impractical to build some logic there regarding to network or file stack. Just a sample. Yep. So let's go further to the next slide. Just 1 second. Yeah. So as we're talking about cybersecurity tools, on this slide we have a sample.
Maybe let's summarize. Yes, and previous part of our webinars were related with some main structure of operating system. Yes, why we can and where we can use and for which needs and goals we can use kernel level. Yes, and kernel functionality and to extend some type of functionality. And for the which type of work we can use user mode functionality based on maybe some hooks, API, multi-threading using. And so now we can say that really, to be honest, in our cybersecurity market, we already have some type of existing tools which you can use for your needs. So you don't need to implement everything from scratch. Yes, you can reuse something already on the market, and you you can reuse it for your needs and to use these results in your project and your product.
Yeah. So this is exactly my point too. So this slide about this sample, this is a couple of tools which are widely used for event monitoring. So it's like the incident detection and malware detection cybersecurity tasks for them. So, and this is like a kind of very well-known setup on the market, and what people usually use for improving Windows security. So, first tool which is widely used is for detecting malicious activity is Windows audit policy. So what is it? So you can instruct the Windows kernel to produce events, logon events, account management, object access, group policy change. And the kernel itself is a trusted source. And as we said, it protects itself, so it's a good option to have reliable data source for some events. So, for example, for malicious activity detection. And next very popular thing, which is kind of similar but more extended, is Sysmon. Sysmon is, as you may know, popular security tool which is written by Microsoft and logs system activity in event log. It can be configured to log the process information, modules information, networks, loading of drivers, and interesting thing is network connection. You can log a network connection too. And there are nice templates on GitHub where security people collect rules that cover different threat activities, scenarios, and so also nice tool. And the core, as you may know, the core of this project is a device driver, this sysmon DRV. So it also a kernel mode component which produces necessary information for us. Another interesting component is which was also widely used on security market is WinPickup, as you can see here, WinPickup. If you have ever used the Wireshark tool, WinPickup driver is the main default data source for it on Windows. And this driver collects raw packets, network packets, and the UI tool allows you to inspect the traffic, actually. And also, there is a special driver on Windows, this name NDSCAP. Windows usually contains a driver which is similar to WinPickup, which is used by internal diagnostic components. But it's built in, so typical Windows installation already have one. Disadvantage of this solution, actually, it's good and nice solution. How to let's talk about the good side. So good side is that you can set up this solution, collect a lot of information, and put it to some storage like Elk or Splunk, and then turn up some alerts, which will alert you if some malicious activity happens on your enterprise. So it's like popular setup. As I forget, also I forget to mention osquery. Osquery, I have osquery in slide, but I forget to mention it. It's a user mode tool that allows us to write SQL-based queries to explore various operation system data. So you can explore a running process, loaded kernel modules, network connections, so on. So a lot of information, including even browser extensions, file hashes. It's absolutely, it has a lot of plugins, and it's a nice user mode tool which can provide a lot of information. But not like notification. You need to kind of ask it to do some stuff. And so it's kind of the typical setup you can meet on if you do some security somewhere, and it has disadvantages for sure. So it generates a lot of noise. It usually generates false alarms. For example, a lot of alerts can trigger alarm when it find, for example, when the rule finds that you have CMD which is hidden from the user, which is hidden from user, which user didn't start. So some kind of and if the developer just starts compiling activity, it usually produces a lot of alarms, like something terrible happens on your PC. Yeah, limited functionality. If you develop in your own cybersecurity tool, you usually have your own vision, which improves this, which is better than the tools which are on the market. Yep. And one thing more, intruder may be aware of it, so build the setup, train attack against the typical configuration, which is also bad thing. So, but this example, why we have this slide here, is that it shows it is necessary to combine kernel mode drivers and user mode tools to achieve the goal of improving Windows security. So it's good for our main idea of this lecture, this webinar actually. Yeah, this can be the basis for incident and intrusion detection as well for malware.
Yes, we will prepare the very long lecture.
Okay, let's go. Now let's go further. What about driver functions? What drivers we usually do? What are functions of them? So we prepared some categories, some main categories, which usually can be used for security products. So first category is about system monitoring. So this is very similar to previous slides. So usually we can develop a driver which does some simple this system monitoring, monitor some process threads, modules, notifications, some activity, some Windows provides a lot of callbacks, a lot of documented and not documented callbacks about and fires them if something changes in the system. Also about registering changes, system handles, and other notifications. So a lot of stuff of interest can be found there. And yeah, another interesting part is security tasks. So here goes integrity verification task, low-level disk file access, self-protection, and other protection capabilities. So I wrote it on the slide here. Yeah, so it's like first component. Another one interesting part which we usually do is file system stack.
File systems. We need to stop on this item
okay.
Yes, this is the most from my side. I participate in a lot of our drivers project and beginning from the pre-sale stage. And what I want to say, this is most popular request to our company. It seems each cybersecurity product should have your own file system filter driver with your special needs. Yes, and so we cannot implement some ready solution which we can reuse for each product. Yes, and because maybe in the several more than 10 years ago, when in the Windows we implemented filter drivers based on the legacy technology, yes, but now in the Windows already embedded their Windows framework for mini filters, and this is like skeleton, yes, for the such type of driver. But each time we need to implement this solution, this driver, like from scratch, even because each request with some nuances, with individual request, and for the kernel level, it is very sensitive, and so we need to do this special architecture, special solution for each request. Yeah, please continue with that.
Yeah. So yeah, it's a huge area. Also, a lot of possible tasks in the security market. And yeah, what is file system filters? It's just some term. Microsoft created the concept of mini filter drivers, which act like a plugin to a special filter manager driver, and the mini filter driver attaches to file system stack indirectly and receive input-output operations, notifications, can modify them. And yeah, and actually mini filter chooses what activity to filter, it wants to filter, and can be useful for various tasks, for example, for events monitoring, for events data monitoring, for custom access control, for file redirection, content, file content virtualization, different virtualization tasks, for folder virtualization tasks, for backup system and software rates, and this like low-level tasks. They can be used for different categories which relate to cybersecurity. Like you see them on this slide, like it's custom access control, malware protection, sandboxing, data backup and recovery, data encryption. This task usually handled by my mini filters very well. So a lot of activity goes there. So yeah, and also if we are talking about file system stack, Windows also have concepts of storage devices, ports, mini ports. So here goes drivers of disks, of volumes and stuff. And we also, yeah, do drivers for virtual devices here and for virtual volumes or virtual disks, mainly for data encryption, data backup and recovery systems, and so on. Yep. Let's go to another interesting stack, like network stack on Windows. So
Interesting slide.
interesting slide. Yeah. So let's see. We have simplified overview of Windows network stack. And as you can see here, here we have main components like network hardware on the bottom, network hardware, and can be network card or Wi-Fi adapter or something like that. And actually client software on the top. You can see, I can't point in this presentation, so that's why I need to talk where you can find it. Yep, and Windows from, you know, it's from the top, from the bottom, and on the slide you can see actually Windows kernel socket implementation, TCP stack, and special part below, NDIS subsystem. You can see three entities which provided by NDIS subsystem. NDIS stands for Network Driver Interface Specification, is a standard interface between low-level layered network drivers. And it provides a couple of abstractions as miniport, which handles actually the device. And this intermediate, which kind of has another name as a virtual miniport, protocol driver, and filters between them. Yep. And these filters are good for example, for firewalls. They're good for traffic injection and modification. Network data can be filtered and modified before it reaches destination, for example. And NDIS filters, they are good for traffic encryptions, good for work with separate packets. But it's nice thing is that they can collect the packet information from the lowest possible level, which is available for software. So next level, as you can see on the slide, is only hardware level. And if you use Windows capturing solution, for example, like Wireshark, it usually installs this filter, yeah, because it really wants to handle raw packets as raw as possible. But NDIS approach, it has some minuses, like it is first minus is its relative complexity because of a lot of work on interrupt level. You need to be extra careful there because of a lot of internal stuff. We don't go there right now, but but it's kind of tricky.
One of the main challenge for this layer to support consistency of the data which you are controlling and monitoring on this layer. And because if you would like to change something with network package, so it really will be impact for the performance, and so also it will be impact for the transferring of data. And so that is why you need to at first to pack and after that unpacked in the right way. Yes, and it will of course add additional difficulty, and you need to expect some
sure and
implementations. Yes.
Yeah, and these types of low-level drivers, they don't have much user and process context. When you handle some network traffic, you usually don't have it, and you need to do some special actions to associate your traffic with some user and process context, which is usually something you need to do. And it can be Claudia is said, by the way, this item already, that NDIS drivers can be not the best choice if you want to work with TCP streams rather than separate packets. I would say like that. So if you need to work more with separate packets, it's best solution, absolutely. But if you need to collect the entire stream, and then, for example, for some purposes, it could be tricky. And that's why Microsoft offers Windows filtering platform. So a special platform for creating network filtering application. And the difference of NDIS level is that it provides a lot of callbacks from different levels, from several layers of this stack. So we have a lot of callbacks. You have installed handlers on the top of TCP stack. You have installed on the bottom. You have installed various callbacks for traffic redirection. So, and Windows filtering platform, it is good for example, for TCP stream analysis. It's good for traffic redirection, and it's good also for accessing process and user context. For example, top-level filters can access it. And but it in modern versions of operation system, Windows filtering platform can access low-level packet filtering too. That's why VFP and NDIS, they're interchangeable in some abilities, but mostly they provide unique capabilities, mostly. So it's like that. Now we go to the, so this is the end of network stack. Let's go to another areas of beautiful kernel mode programming. Yeah, and so this is like this slide summarize previous one a little bit. So if we're talking about cybersecurity area, both VFP and NDIS, they are good for monitoring different systems, for firewalls, for traffic inspection, for traffic encryption as well. And there is also one area which is not covered by previous slides, is USB. USB human interface devices. So this is drivers for web cameras, for fingerprint, other biometer, which also can be related to cybersecurity area. We have a lot of expertise with network redirection of these devices and the virtualization of them. So
yes, we have experience not only with implementation drivers for the custom devices itself, yes, and so we also have exactly for the cybersecurity domain, and especially for remote access solution when you need to redirect your devices from the client machine to the server to the host and manage these devices with this some right list of permissions. And so our company have a lot of experiences with replication the real device to the some virtual device and manage it in the virtual environment. Yes, and it is not only for the remote access solution, it's also for virtualization solution, also for the cybersecurity, which is based on the hypervisor, yes, like Kernel, KVM, and ES6, and Hyper-V by Microsoft, yes, and so. Mm-hmm.
Yeah, so I think this is it. And yeah, questions. So here we go. Here we go to questions because we out of slides regarding kernel user mode and
very good. And Victor, I have question. And according to file system, our favorite topic, yes, and for the files. For many filters for the file operating system and hooks and libraries for hooks. Could you please explain some cases for which it's reasonable to implement and have the mini filter, and because it is easy, yes, and to have some one driver which will monitor and control everything for some special rules, yes, and for which cases we need to use hooks. Yes.
You mean do you mean this user mode part, user mode approach with user mode hooking and stuff? So this is exactly the area where mostly we prefer to use mini filters because of they are most flexible and powerful and stuff. But sometimes some driver people might not have, for example, certificates, and in some cases it is possible to use user mode hooks also if you have some very kind of I would say
maybe
small yes, very small operations which doesn't include any activity regarding file data, for example. So if you can collect, if you want to somehow or collect file data, or if you want to consistent file data, I would say, and if you want to modify it somehow transparent. If you want to do encryption, it's very tricky to do in user space because of you need to handle a lot of APIs. You need to handle memory mapped files. You need to handle different synchronization schemes like EO ports, because of a lot of user mode code usually use them for files too. You need to have to handle a huge set of API. File API is very huge in user mode in Windows. And yeah, this is why if you need to work with file content, it's definitely a huge call for having mini filter.
As I remember,
there are more, but this is the main one.
I remember in the low level, in the kernel level, anyway, file operation they are limited, so we have like limited. So it's like create, delete, and so we can filter the limited type of operations. Yes, and if you have in the some special operation, like for example rename file, yes, it will be handled on the kernel level like delete and create. Yes, so in the kernel level we don't have the some special operation like rename, and for this type of operation, for example, yes, and in the target application we will need to use like hooks for the each of these application.
There are some, even we have, even there is special Microsoft certified way how to there is a special case when we or people need to actually handle user mode calls because of it is very tricky. You have to get the context information in kernel mode.
And
Yep.
we also
There are some cases like that. It is like regarding move and file deletion sometimes, but yeah.
as you mentioned,
Yep.
and also managing content according to
Yeah.
intellectual property. Yes, and when people want to protect, this is very important for DLP solution. Yes, and when people don't want to have your data stolen and to do some copy paste from the special application, and so they need to work with hooks, not with the mini filter. So mini filter can be used like the trigger, yes, and something happens in this application and this file, and but after that we will need to use the hooks and some additional
Yeah. Sometimes to get some additional information. Yep. So user mode hooks, they are good for getting some additional information, doing some special small actions.
Okay.
Not like for getting the entire
Guys
file
are waiting
content
for
or something like
other questions, and one more question is related to maybe not with the Windows driver and for the Linux driver and like comparison. And could you please tell if some difficulty for the new version of Windows for the drivers? Yes, and for Windows drivers, and because as you know, for the Linux, there are some for the new core of the Linux. This is like new challenge to rebuild. Yes, and the Linux driver.
Yeah. So I understand the question. Yeah, I understand the question. So so Linux kernel is constantly changing, and if you develop some driver, you may find that on the next kernel you can't even compile it without errors. Someday you go to work and you can compile your driver because it is new kernel available. So in Windows, it's not like that. In the Windows, first thing is usually we have a stable interface, and Microsoft, they care about it a lot. So I never met the case when they, for example, add some parameter to existing function of stable interface or remove it, which happens in Linux world constantly. Not constantly, but pretty often. And another thing is currently the situation on the market is changing, and nowadays a lot of people they order the products for Windows 10, Windows 11 because of most people use them, and we can develop a driver, for example, for Windows XP for old versions for Windows 7, but not a lot of customer doesn't really want them. So it's something, there is some aggressive policy of updating on the market, and a lot of people, they already use Windows 10 and Windows 11.
One of our customers in this week requested that they need a driver for XP because they have special clients for the
it happens sometimes,
with
but
some special certificates, and
but
so they cannot to move to the newest operating system, and so that is why. But they need the product, yes, for this cybersecurity needs, and so that is why it happens.
this situation can be this happens when you use embedded systems mostly. So Windows XP and Windows 7, we can meet them on some embedded market, and even statistics from the internet, from different sources, they pointed that like new desktop software mostly use Windows 10 and the later operation system, but on embedded market still have humanity have a lot of boxes with a Windows XP, Windows 7 and stuff, embedded versions of it. So IoT platforms and stuff. Yep.
Okay, thank you.
Special versions which actually Windows embedded.
Thank you, Victor. Okay, and the last question related to estimate and how many time can be required for the implementation of the some driver.
It can be different for different purposes, for sure, because of as we as we saw, even mini filter can be used for various purposes, and for sure, estimate may vary, and yeah, but it's usually a little bit. I would say if you don't have certificate, for example, it would take more than 2 weeks because of even if you buy certificate, you will have it in a month. So it's like that. So it will be in months, definitely, because if you don't have any certificates and you don't have any experience, if you don't have some laboratory or some stuff, so you need a lot of preparation for it, and this preparation stage they use time, definitely. And yeah, so this is kind of entry level for kernel mode development.
Yeah.
the line, yeah, you really can't deliver something in days. It's impossible. For some kind of user mode programming, it's possible to have some expectation about you can build some application and deliver it in days sometimes. And the driver, it's usually more interesting. Yeah, if we are talking about building driver from scratch, it takes weeks and months usually. So, but there are some tasks which are already. So Microsoft provides a lot of free samples. They are good. They have well-known. If they have some issues, they are well known that issues, and most people use a lot of free code as a base for their systems. So
Thank you, Victor. From my side, I couldn't estimate. It's really, I can say, so it depends on the type of drivers, depends on the functionality which you would like to add to this driver to have this your project, your product. And so it's really, it can take 1 month, and sometimes it can take 2 years with several kernel developers who are assigned to this project. Okay. If you have any questions, so I think we will finish with our webinar, and so we already will get about 1 hour. And so if you have any additional questions, you can write me direct message. You can write to Victor, and you can write to our company, and we can help you from the technical side, from the vision, and we can consult you according to kernel development for the Windows, for the Linux, and for Mac. And I hope the next hour webinars we will do for this operating system and for Linux and for Mac OS, and because especially for Mac OS, it's really very interesting situation. I think a lot of you know about the new updates and the new version of this operating system, and a lot of functionality were deprecated, and they're provided new functionality for driver development. And so I hope we will prepare the next webinar related to this macOS development kernel extension. And for now, thank you, Victor. Thank you, everyone who visited, who participated in our webinar. I hope it was very useful and you find something interesting for you and for your project. And so have a good day, have a good evening, have a good holidays, and so coming soon Christmas holidays. So, and thank you for your time with us. Yes, bye-bye.